Another great way of estimating the probability of some event is to use data. We've talked about writing a Monte Carlo simulation to estimate probabilities, but what if we've collected data on a whole bunch of different customers or individuals, and we'd like to estimate the probability a customer would buy a certain product? Well, if we had a rich transactional database, we could go back in time and basically treat each customer like a trial and see what fraction of customers have purchased that product. That's probably a decent estimate of the probability of buying that product. And so we want to learn about how we can use data, merge together different data sources to help us estimate these probabilities. So we're going to talk about how we can combine different data sets, summarize different data sets, both in R and in Tableau, to help us out with looking at probabilities and just understanding the individuals in our data. Now, the overall goal when we are doing data analysis and working with data files is to end up with something that we refer to as a flat file. Now, a flat file basically just says everything you need to know about your problem lies in one data file. So here's an example that talks about Kickstarter campaigns. This comes from Kaggle, actually. A student in fall 2020 pointed out there's a great data set that talks about whether or not Kickstarter campaigns have succeeded or failed. And we might want to study something about the probability that a campaign would succeed based on its goal, or where it's based out of, or the currency. And so at the end of the day, what we'd like to find is something like this. We would like a file that let us know, okay, each row corresponds to some sort of campaign. We have the status of whether that campaign succeeded, if it failed, or some other outcome. And then we have additional characteristics. Everything we need to know in order to perform this analysis, figure out maybe the probability of failing or succeeded for various goals or for various countries, is in this one file. Now, very often, that's not what we actually start out with. For the most part in analytics, data is warehoused because it makes sense to do so. We're not going to have one data set that contains every single aspect of the company. The data that we might need could be spread over many different sources. So, for example, imagine we were working for a telecom company and we were interested in the problem of customer churn. So someone's contract is up, we want to know if they're going to renew, or if they churn, they leave for another company. And the data might be housed across multiple different files. So what might we end up seeing? Well, we might have one file that goes through each customer, talks about how long they've been with the company, and gives an overview of what products they subscribe to. Their phone service, yes or no, what kind of contract they're on, what their charges were, and ultimately if they ended up churning at the end of their contract or not. Now, if we wanted to treat each customer like a trial and look at the fraction of trials where our event of interest occurred, the fraction of customers that churned, and we wanted to break this down by, say, demographic information, well, there's no demographic information in this data file. Instead, what we'd have to do is look at a different data set, maybe a customer data set, which has customer IDs and their gender, whether they're a senior citizen or not, if they have dependents. And we might even want to dive in really specifically and say, okay, well, of women customers that subscribe to, say, a streaming service, what's the probability that someone's going to churn? And while we have some basic idea of what they were subscribed to in the churn data set, ultimately, whether or not they are streaming movies or streaming TV lives in yet a third file. So very often, this is how data looks at an organization. It's going to be warehoused and spread across multiple files, and you'll need to combine them together into a flat file so that everything is going to live in one place, and you can answer the questions that you have. So we can't do analytics as is, usually, with the raw data sources. We need to learn how to merge together data sources, aggregate the information that means something to us in order to start doing the analysis. So if we want to know what fraction of females who have been customers, say for at least 3 years, and who have signed up for streaming movies, what fraction of those customers have churned, we're going to have to combine information from 3 different data sources. Now, there are three main commands that we use in R to help us do this. And the three commands are rbind, and that is if we need to essentially stack one data file on top of each other. So, for example, if we wanted to study song characteristics of popular songs, well, there's a great data set up on Kaggle that has scraped data from Spotify, and we have a separate data file for the 1950s, the 1960s, 70s, etc. We'd like to essentially combine these files, just stack them on top of each other. They all have the same format. We have something about the title, the artist, the beats per minute, the energy, etc., characteristics that Spotify measures about each of these songs. We essentially want to take all of the songs in the 1960 data file and add them to the end of the 1950 data file. Now, if we were living in Excel, this would be a big pain in the butt. We could go and copy all these rows. I'm sure there's a much more efficient way. I'm not an expert at Tableau or at Excel. Paste it there. Delete that. We don't need that row. Go on to the next data file. And we're going to get really bored of this really quickly. This is pretty tedious to go through by hand and do this for every single one of these data files. And hope we get it right the first time. If we mess up, well, it's back to square one. There's got to be a better way. And there is, of course. R and other software packages have the tools to quickly essentially stack data sets on top of each other, what we're going to call the append operation, and we're going to be using the command rbind in R to do so, R for rowbind. Now, once we've maybe stacked all the data sets on top of each other, that's a good first start, but maybe we need to merge different data sources together, much like we would need to merge the demographic information, the plan information into the transactional data for the telecommunications company in order to study what's the probability that a female who's been a customer for at least 3 years and who streams movies is going to churn. And so the merge command in base R is what we'll use. In SQL, you'll learn a whole set of operations that'll allow you to do this sort of merging as well, and this sort of appending. And once we've collected the data into a place where we like it, well, we might actually want to do some aggregation. We might want to look at, say, averages across groups. And in fact, that's exactly what we want to do when we're estimating probabilities. If I want to know what fraction of females that have had a tenure of at least 36 months and that stream movies, I need to do some aggregation, group together all those groups of customers that I'm interested in, and we'll look at the fraction of those customers that have churned. So we might apply these three different operations in different orders, but at the end of the day, our goal is to come up with one big old flat file where we can do this analysis. So we'll do this in R, and we will learn how to do this in Tableau as well. So first, let's visit that Spotify example. So we opened up our data folder, and we give a little bit of a frown because we see a bunch of different data files from 1950 to 2010 that we'd like to stack on top of each other. Basically make one big data file where the rows from 1960 follow the rows that we saw in the 1950, 1970 after that, etc. So one thing I can do is I can read in those separate data files into R, and I've pre-written these read.csv commands. The only thing that I'm going to add reflects a change in R 4.0. So by default, back in the old days, when you did a read.csv to read in a comma delimited file, if there was a text variable, basically a categorical variable like gender, it would automatically treat that as a factor. R's word for a categorical variable. It keeps track of the levels, the possible values it might take, and R no longer does this. It stores any sort of text field purely as a text expression. So if I were to go choose where this data file lives so that I can read this in correctly, if I read in with read.csv, you'll notice that the title, the artist fields are just pure character vectors. Thumbs down. I don't agree with this change from old R to R 4.0. I would much rather have the text fields read in as categorical variables. Now it's an easy enough change to make. All we have to do is add in stringsAsFactors equals true. And once we do that, and here's why I like it, we see that R is treating those text columns as factors. And the reason I like it is that it tells us how many levels there are, how many different values I see for that field. So let's go ahead and do some copy pasting and go ahead and get all of these data files into R, and we'll illustrate the rbind command. All right, so all of these data files look basically the same. If I look at the first few rows of music 50, the first column is called number, the second column is called title, third artist, etc. In order to stack the data sets on top of each other, you need to make sure that those two data sets have the same number of columns, and each of those columns have the same set of names. So if I look at music 50 and music 60, that looks to be, pretty reasonable. I could always get the names of these different data sets through the names command, the names of the different columns here, just to verify that I'm dealing with the same set of fields. And when that's the case, R is going to allow me to do this. I'm going to create a new data frame just called music, and I'm going to left arrow the result of running rbind on these two different data sets. So here's how rbind works. We're going to give it two different data frames, and rbind is simply going to take the data frame in the first argument and then add to the end of it, add additional rows, all the rows that we have in the data frame in the second argument. So running this, what we find is that music has 170 observations. Makes sense because 73 plus 97, 170. They've been added to the end of each other. Now, one thing I don't like about rbind, though, is that it only allows you to do this to two data frames at once. I can't give it a whole list of data frames that I want to have stacked on top of each other. So I'm going to have to copy and paste and modify this command to get every single one of those data files added in one by one. Now, here's my trick. So I've added the music 60 data to the end of music 50. I've called that music. I'm going to rbind music, what I currently have, and I'm going to add music 70 to the end of that. So once I do that, music is now 274 observations. We've added in those additional observations from 1970 here. And I'm just going to continue to do this. It's a bunch of copy pasting. Boop, 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 boop. You could write a for loop that would automatically go and do this for you, but by the time you figured out how that for loop works, it's probably faster to just copy, paste, and make modifications. So 50, 60, add 70, add 80, add 90, add the 00s, and add 2010. So now, music has 667 observations, and we could look at a summary. There's attributes of songs that were popular across the last 60 or 70 years or so. So rbind isn't really all that bad, and it's going to be very useful, especially when you run into situations like this. So this is a set of data files that was given to us by a major bank, I'd say about 8 years ago. There was going to be a hackathon with the MSBAs, and they were studying what types of items various customers purchased. And what kind of data did we get? Well, the way that the data was being stored is that each customer had its own separate data file. So in this case, if you can see the numbers attached with the customer in the file name, there are that many customers. Here in this case, we'd actually want to run a for loop. And in this case, if you have a Mac or if you have Windows that's able to open up a Linux shell, let me show you something really quick. I'm going to open up the terminal on my Mac, and I'm going to go to this folder. Now, you'll learn a little something about how to use Linux or Unix commands here. If I type ls, that's basically listing all of the files in that folder. And I'm going to ls, put this symbol, and I'm going to call it filenames.txt. Basically, it's going to take the output of running ls and then shoot it into a file called filenames.txt. Once I do that, you'll notice that in filenames.txt, I have a list of all the file names. along with file names.txt, ls. The way Unix works, it's interesting to say the least. I'm going to go through and actually remove that. I'm going to save it. I'm going to close it. So here's how I could do this really quite efficiently. I'm going to change to the folder that has all the data files in it. I have to bleep that out. And let's do this. So let's scan in the file list.txt. Boom, 50 files here. So check this out. I'm going to say customer, left arrow. I'm going to read.csv, the very first file name in that list. And I'm going to do stringsAsFactors equals true. So here's our first customer. 1,568 transactions, 10 different items of information associated with those transactions. And I'm going to write a for loop that goes through each of those file names and rbinds it. Just really nice and efficiently here. So I'm going to say customer, left arrow, rbind, customer, and then I'm going to read.csv files bracket I. So the second element of files, which is my vector of file names, with the stringsAsFactors equals true. All right, so once I do this, cross those fingers. We got some warnings. What are those warnings here? So we could get a summary of customer. And so we'd have a good idea of these 50 customers, distribution of amounts, where they're shopping, the distance from the store to where they were making that purchase, etc. So if we run into a situation where we do just have to stack a whole bunch of different data sets on top of each other, rbind and R is very useful. And if you have a lot of data files, writing a for loop to automatically go and do this is very helpful. Now, Tableau is another great piece of software for doing data manipulation, and it allows you to do visualization, aggregation, all these great sorts of things. So how does Tableau work? How can we get it to stack the data like the Spotify data? Essentially add in the rows to 1960 to the end of the file for 1950, etc., etc. So I'm going to head on over to open up the text file. And I'm going to navigate to where the Spotify data was. And we're going to start out just by opening up the 1950s song data. So once I've opened up the text file, all CSV files are text files according to Tableau, it's going to bring up a data interface. Now, one thing I like about Tableau is that as soon as you open up a particular file, it actually shows you what other of those similar type of files lives in that folder. So what we would like to do in Tableau speak is to create a union. Essentially add the 1960 to the end of 1950 and so on and so forth. So we actually have a new union button that we can click and play around with, or we can just double click on the 1950.csv here in the field. I'm going to double click that. That changes the interface a little bit, and I'm just going to drag 1960 to the bottom of 1950. So drag table to union, we drag it, this becomes a plus, it's made of two tables. And you'll notice that it's actually added an additional column if you go and scan to the far right that tells you what data file that comes from. So it's as easy as saying, okay, well, let's add in 1970 to 1980 to 1990, 2000, and 2010. Now, obviously, if there's 100 files, that's going to get a bit tedious. But if you're dealing with a few files you need to stack on top of each other, Tableau is pretty nice for doing that. Now, if you head over to Sheet, you can just check to make sure that that happened by dragging the field that was letting you know what data file it was coming from into one of these columns or rows so that you can see, all right, well, here's the representation. So I'm going to drag table name to columns, and we see that we see stuff from everywhere. If we drag table name to the other pill and measure the count, here's a bar chart of the number of times we see songs from each of those files. So stacking, the rbind equivalent, not a problem in Tableau. I think the easiest thing to do is just to drag the first file, double click on it, and then just drag the files underneath it.